Hi, my name is Zahir Foster, and I'll be talking about how dangerous boxing is on the brain. A little background on boxing. Boxing is a sport that has been around for thousands of years, becoming an official Olympic event in 688 BC. In today's world, boxing involves two athletes punching each other with padded gloves, trying to knock their opponent out. These fights usually last 3 to 12 rounds, with each round usually lasting 3 minutes. The Hilbert boxing study done by the Department of Neurology at the University of Heidelberg Medical Center utilized high-resolution MRI data to search for tiny changes in the brains of amateur boxers and non-boxers. 3 out of the 42 amateur boxers showed microhemorrhages or microbleeds in the frontal or temporal lobes where the shear forces of blows are strongest. None of the 37 non-boxers revealed any changes. These small changes in the brain are most likely precursors for later severe brain damage such as Parkinson's disease or dementia. The photo on the left, where the frontal lobe is in the red and the temporal lobe in the green. The photo on the right shows the MRI scan of the brain. Photo A shows multiple CMBs, cerebral microbleeds, in the parietal lobe, and in photo B are multiple deep CMBs in the bilateral basal ganglia and thalamus, indicated all by these black dots. It's unknown how often microhemorrhages occur in boxers. Repeated strikes on the head may eventually lead to the destruction of brain cells and deficits, as aforementioned. A follow-up study is necessary to compare MRI results between amateur and professional boxers in order to assess intensive exposures to blows. A disadvantage of the study was the great range in duration and intensity of amateur boxing. Duration among participants ranged from 1 to 25 years, and intensity varied from 1 to 375 bouts and 0 to 12 knockouts. A study of the American Neurology looked into individual concussions as well as overall permanent brain injury at its early stages in fighters to determine which fighters are at greatest risk for long-term complications. They looked at data over a 5-year period and found elevated levels of two brain injury markers in the blood: neurofilament light chain and tau, which are components of nerve fibers that can be detected in the blood when the fibers are injured. Researchers questioned whether the presence of these brain injury markers are indicative of permanent traumatic brain injury with long-term consequences. Researchers took samples from 291 professional fighters with an average age of 30, 44 retired fighters with an average age of 45, and 103 non-fighters with an average age of 30. They found that active professional fighters had higher levels of both proteins compared to retired fighters or non-fighters. The levels of neurofilament light chain were 40% higher in active boxers than in non-fighters. They also found that the more a fighter sparred in 2 weeks before the blood samples were taken, the higher levels of neurofilament light chain in the blood. While neurofilament light chain was higher in active fighters at the start of the study, levels didn't increase significantly during the study period. But there was a group of fighters who showed increasing levels of tau over time. Neither age, ethnicity, or number of professional fights in active fighters were linked to levels of either protein. Researchers also looked at brain size and found that fighters who had increasing levels of tau over time also had 7% decline in the volume of their thalamus. The thalamus is located in the center of the brain, indicated by this yellow portion, and regulates sleep, consciousness, alertness, cognitive function, and language, while also sending sensory and movement signals to other portions of the brain. Researchers found that the higher levels of neurofilament light chain did not do well on computerized tests that measures the brain's processing speed compared to the retired fighters and non-fighters. They also concluded that the higher levels of both proteins may be associated with repetitive head trauma. Nevertheless, neurofilament light chain may be more sensitive to acute traumatic brain injury, whereas tau may be a better measurement of cumulative damage over time. More research is necessary to see how these protein levels may be used to monitor a traumatic brain injury and neurological consequences over time. A limitation of the study was the difference in the average age of the active and retired fighters. A study conducted by the University of Stirling, which assessed boxers before and after 9-minute sparring session. A sparring session is whereas the athletes trade punches without the aim of incapacitating each other, compared to previous studies that looked into effects of heavy blows inflicted during competitive fights. This study looked at subconcussive impacts inflicted during training sessions. This clip shows a sparring session. Researchers assessed the motor control and cognitive function of 20 boxers and Muay Thai athletes before and after a 9-minute sparring session, 3 rounds of 3 minutes. Measurements were taken immediately after the session, then 1 hour, 1 hour, then and 24 hours. Motor control was measured using transcranial magnetic stimulation, which uses magnetic fields to stimulate the nerve cells in the brains of participants to understand how it communicates with the muscles. They also complete a series of tests called the Cambridge Neuropsychological Test Automated Battery, which provides objective measures of cognitive function. Results after 1 hour of sparring. Results showed that after sparring, participants showed impaired brain to muscle communications and decreased memory performance. After 24 hours, these effects returned to baseline. Researchers concluded that brain changes observed after sparring are reminiscent of effects seen following brain injury. In the short term, this may negatively affect fine motor control and thus athletic performance. It's not possible to say whether there is a safe threshold when it comes to the level of impact in sparring. Further research is required to help the sports and academic community to fully understand the dangers posed by subconcussive impacts routine in sports and measure that it can be taken to mitigate these risks. So, what can be solutions to prevent or treat these injuries? Well, a study led by Rihi Shai, a professor of neuroscience and biomedical engineering at Purdue University Department of Basic Medical Sciences, reports that checking urine within 7 days of following a brain injury could be less invasive, faster, and help reduce the risk of long-term health issues. In the research study, a urine analysis tested an increase of ele- elevation of aerocline and oxidative stress within 1 week of the following neurological injury. What's important is that the urine test can be performed much easier than blood tests or more invasive medical procedures currently available if a protocol is established routinely test urine following a traumatic brain injury, then treatment options can improve earlier and potentially offer better long-term outcomes. In this clip, neurosurgeon Dr. Martin Scorsese states another method to prevent and detect traumatic brain injuries in boxing. So, as with risk in any contact sport, it is wise for individuals in in the sport of boxing to be aware of the risks in climbing into the ring, and sports community to put better efforts in keeping boxers safe and alive.